Welcome back. This is part 3 of chapter 6. Starts on page 220. And this section is going to be all about growth and the types of growth that we see. It's going to start with like ossification, bone growth that is like when you are increasing the size, the diameter of a bone, and this happens to maintain your bone all throughout your life. We're also going to talk about ossification of when an infant, although that cartilage is replaced with bone, and then intramembranous ossification, which occurs on mostly flat bones. So the first type of bones is going to involve, and I'm sorry, that's why I'm confused here. Let's go back to where we would be starting right here, appositional growth. So this has to do with increasing the bone diameters. This involves all of those cells that we talked about in one of the last sections, the osteogenic cells, the osteoblasts, the osteoclasts, and the osteocytes. So osteogenic cells, they are going to be your stem cells, your bone stem cells. They're found under the periosteum, and they're able to add these concentric layers. This is where once you add a layer, your osteoblasts, which are increasing the deposition of calcium, they are actually going to become trapped, and then they mature into osteocytes. So here you can see like the different layers here, and these osteocytes that we looked at last time, those are trapped in these concentric layers. So this, if you can kind of look at this as an infant, you know, you're small, your bones are smaller. So how does that become bigger? Well, one of the ways is by appositional bone growth. That's going to increase the diameter. And you can see from the center there that the osteoclasts are what are breaking down the inner portion there where the medullary cavity would be. And then the osteoblasts are putting more layers on the outside. So what you end up happening is this increase in diameter. It's not, but the thickness remains pretty consistent. That layer, the periosteum, this is a picture from page 221. And this top picture is kind of like a cross section of the compact bone. You can see the periosteum here is this layer right here, okay, that wraps that superficial part of the bone, of the compact bone. There's a fibrous outer layer and a cellular inner layer. This is going to keep the bone different from surrounding tissues. So there's a lot of tissues that actually touch and hold on to the bone. The periosteum keeps it separate. There's also vascularization against this, so it's a route for blood and nervous supply. And this is an active bone growth and repair areas. Okay, I'm gonna try and move myself here. The perforating fibers here, that'll do. The perforating fibers, if you look at these blue, and it's much better on your book on page 221, but these blue lines here, those are going to help attach the periosteum. It's a very strong attachment, and it will, because you've got all these other tissues like tendons and muscles that are pulling on the bone. This perforating fibers helps to keep that periosteum strong so that bone will not break. Endosteum, so we're not looking at the cross section as much anymore. We're looking kind of at this inner area here of the medullary cavity. So this is the cellular layer that is lining that medullary cavity. And this is a very active area during bone growth, repair, and remodeling. Against it is the spongy bone and that central canal. This is remodeling. When we talk about remodeling, we talk about the osteoclasts and osteoblasts. And so here you have some osteoblasts and osteoclasts. Osteoclasts, as the diagram's trying to show you, they're in these crypts, these depressions, and that's where they're starting, because that's where they're started to break down the bone. And then osteoblasts are trying to build it back. So when we talk about remodeling, that's kind of, we're talking about the balance. Okay, so that is the first type of bone maintenance. And there's a lot of problems. So, like osteoporosis and osteopenia and all that is when there's an imbalance in your osteoblasts and osteoclasts. You have more breakdown than you have built up. The next type of ossification or bone growth is endochondral. So that endo means within, and that chondral refers to cartilage. So we're talking about taking the cartilage and gradually replacing it with bone. And so now we're talking about bone growing in length, not width, but bone growing in length and width. So the steps are across pages 222 and 223, which are fantastic pictures of these lovely areas of bone growth. So if we start with the beginning, okay, when you're looking at an infant, a fetus or infant, we're talking about small cartilage models, okay? There's not much connections or articulations. It's just kind of like this is a very early fetus. So as this, so we see chondrocytes, which are the cartilage cells within the calcifying matrix. So here we just start with our hyaline cartilage. That's the type of cartilage that we see in most areas of the fetus. And in the center here is where we're going to be kind of focusing. Okay, so then what happens is we start to have this vascularization on the edge here. And there's the beginnings of the shaft. There's the beginnings of the diaphysis and epiphysis, ends of a long bone, right? So at the edges here, you can see the bony formation. And it's a very superficial layer of bone on that side and that side, because the majority of this is still cartilage. Okay, so the blood vessels that we're just touching are now starting to incorporate into the structure, okay? And so what happens is we have this primary ossification center. So this is where spongy bone is starting to be produced. And that spongy bone production just kind of spreads in both directions. Until what you get eventually here is kind of like this spongy bone medullary, almost like a medullary cavity, which that's what they're calling it. But it's still not a bone. But this is where it can grow in length and diameter. So this is where we're getting the lengthening and the widthening. We're also starting to see some heavy vascularization with all of these capillaries and arteries and veins, okay? So then these capillaries and veins kind of migrate, and you get these secondary ossification centers, which are at both ends, and they start to produce more spongy bone. The epiphyses is then filled with a spongy bone. The articular cartilage remains exposed because it's going to be a joint. And then you get this epiphyseal plate. And let's see if I can move this again. And it's the plate between the epiphysis and the diaphysis. So here you can see this cartilage forming, and that's eventually where you will see the plate. You can actually see that in a fully formed bone. You can see the remnants of that epiphyseal plate. It's called the epiphyseal line. So then bone growth, bone grows in length. I just cannot find a happy spot for myself here. There we go. Bone grows in length at the epiphyseal cartilage, and those chondrocytes produce more cartilage. The osteoblasts, continually make more bone. And what happens is you get these epiphyses, the ends, which are consistently pushed away, and that's when you get to bone lengthening. Okay, this is part of, well, it's about to be part of what happens during puberty. So up until this point, it's kind of like going from fetus to infant to toddler to young child. But eventually what happens at puberty, the hormones that are produced during puberty, they start to, and one of those is growth hormones, which help to increase the growth of bone. And that epiphyseal cartilage is replace. And here you can see the line that is the remnant in an adult. Okay, so the bones in a child are growing at both ends to lengthen. My son, when he was, I want to say about 3 or 4, he was quite a daredevil, still quite a daredevil. And he broke, so what he did was he broke his humerus, the head here at the elbow. That's not the head, I'm sorry, the head's up here. Part of the elbow, and it was like a line like this. So it's going kind of parallel to the length of the bone, or the crack was parallel to the length of the bone. And they were really concerned because at that epiphyseal line is kind of where growth is occurring. And so they would kind of measure both his bones. And let me tell you then, the week after he broke one, he broke the other. So, you know, thank goodness he's no longer a toddler, a crazy toddler. Now he's a crazy teenager. Okay, the third type of growth is on page 224 and 225. This is intramembranous ossification, and this is describing kind of what happens when flat bones grow. This begins when you have these mesenchymal stem cells. They become osteoblasts. Remember, osteoblasts do the building up, okay, of the calcium buildup. Okay, and this is going to happen in deeper layers of the dermis. So these types of bones are called dermal bones or membranous bones. So this is like bones of the skull. But there are also going to be other flat bones and irregular bones like sesamoid bones and collarbones. So the steps are across page 224 and 225. The mesenchymal cells are going to cluster, and this is terrible that it's so tiny, but please look in your book. The mesenchymal cells are going to then differentiate into osteoblasts, which you can kind of see down below there. They start to secrete this matrix, this osteoid matrix, which becomes mineralized, becomes harder, and becomes bone matrix. So that's an ossification center, and you can see one of these kind of bubbles here is labeled as an ossification center. Then what happens is these small struts called spicules start to stick out, and that's where osteoblasts become trapped, and those osteoblasts become osteocytes. And we already talked about that in the other types of growth, appositional growth, where the osteoblasts become trapped and then they mature into osteocytes. But mesenchymal cells those stem cells are still producing more osteoblasts. We have blood vessels enter the area. So that's right here. You can see some blood vessels entering. And so then bone spicules meet and fuse, hardening the matrix, and then blood vessels are trapped. So you just have the continuous deposition of osteoblasts, and this results in more of a spongy bone than the concentric circles of the compact bone. So that's why this is a different type of ossification, and mostly in the flat bones. And then you do have some compact bone at the outer layers. Okay, so I actually want to, move myself here. Where we go. So you have some compact bone on the outer sides, the more dense areas, and then you've got the spongier bone inside the fibrous layer. So this begins during embryonic development, very early, 8th week. And then you can start to see the ossification centers at 10 weeks. And at 16 weeks, you've got most of the bones able to be identified at least. Okay, the next section is a clinical module, so we will hold that off until our Friday discussions. On page 228, there's a section review, so check that out. You might want to use that as a way to just check in with what you know about the cell types and the bone, what is it, the bone types, and then maybe some of the